All right. This is one of the most challenging kind of questions on the test. I'm not saying it's a question on the test, but one of the types of things you have to know. And on your homework, sometimes there was stretches that were like so hard to figure out because they had two things going on. Would you agree if this is a parabola and it starts there, that it's supposed to have a dot right there? Have you figured that out yet? That over 1 and up 1 is where you go for all of the functions? Let me clarify what I mean by that. This red parabola, I could say, hey, it's been stretched, and I'm going to show you how to do that kind here today. But you need to first understand what normal would be. If you go over 1, you're supposed to be a dot over 1 and up 1 on all of the parent functions, every one of them. I'll prove it to you. If I was going to graph the parent square root, does it go through 1, 1? And it does. If I was going to graph the parent absolute value, do you get that it goes through 1, 1? So if you see an absolute value, like a V-shape, that's really steep, you can say, well, it's supposed to go over 1 and up 1, but there's nothing there. Apparently, this dot is actually up here. And then you can ask yourself, well, which way did the dot go? It was supposed to go over 1 and up 1, but it actually went over 1 and up 2. Do you get that's a vertical thing? Okay, so you got to compare it with over 1 and up 1. How about the other functions? Same thing. I don't want to draw them all up here, but the parabola goes through 1, 1. Even the weirdest one of them all, which in my opinion is the 1 over x function, that's this guy. Even it goes through 1, 1. This is the only function that I'll let you get away with only graphing 2 points on. But you also need something else, and it'll say it in the directions. Must include asymptotes. This is the only function that has asymptotes. All right, so now, this one would be too difficult to try to stretch it. So it goes through 1, 1, but it doesn't go through 0, 0, and so it would be really hard to tell if this had been stretched or not. But could we flip it? Yeah, we could definitely flip this. Now, this is the weird thing. If I flip it like up, down, like this, do you get that's identical to if I would have flipped it from here to here, left, right? So a 1 over x function, the blue one here, y equals 1 over x, whether you do an outside or an inside flip, that's because if I put a negative here or I put a negative on the outside, it does the same thing. You know what I'm saying? 2 negatives would cancel, and then it's like you didn't do anything. But if you put a negative in front here, then that's technically a vertical flip, which is technically going up and down, but it would have done the same thing as if you'd have gone left, right. All right, and where's the rest of it? Right there. Now, do you get, sometimes kids look at this and they see this function and they go, oh yeah, that's the 1 over x function. And they don't even notice that, what? It's not really the 1 over x function, is it? It's the 1 over the x function, except it's been flipped. Or official word for that? Reflected. So this would not be 1 over x. It would be close to that, negative 1 over x. Now, how would you know for sure? Well, here's a way. I'm going to take a point right there. That is the point 1 comma negative 1. That point right there. If I put that in, if I had thought it was 1 over x, please check yourself on this test. It's so easy to check yourself. You can just say, well, I know 1, 1's got to work. So I stick in a 1 and I put in a 1. And wait a minute, it's supposed to be 1 and negative 1. That doesn't actually work. See what I mean? You can tell that must not be the right equation, because when I put in positive 1, I'm supposed to get negative 1. When I put in positive 1, I don't get negative 1. That's not working. It's because the function wasn't right. All right, so in a second, when I put up one of these that's been stretched, your job will be to check and see, okay, I think I have the right equation. You write the equation. And then you see if it actually works by checking some of the points that are on it. All right, so here's one right here. first off, does it appear to you that this has been reflected? And do you agree it's been moved left? Do you agree, compared to the parent function that would have been a normal v, it's also been moved up? But the hardest part is that it's been, what do you think? Stretched. Now you have to decide whether that's a vertical stretch or a horizontal stretch. And I told you to compare the over one, up one spot. But in this case, that's over one and down one. And do you get there isn't a dot there? So therefore, it's not normal. If there was a dot here, that would have been the normal V shape. So we can tell this one's been stretched. So write the equation for it. And it goes through the point, negative 2, 2. It goes through that point too, and this point also. So you could check any of those dots. And if they work in your equation, you must have the right equation. All right. Now this is the hardest thing. So don't be surprised if this is like, you know, bothering you a little bit. But it's not that bad. Okay. So you're writing me an equation with absolute value and an x in it. And you got to make it all work so that these dots, these points, on the XY chart for it would work. All right. When you're done, which is going to be in a few minutes, these two rows check straight across from you, except there's nobody across from you, so you two will compare with each other. That's fine. And he'll be working with the kid back there, so you two guys compare. And these two rows straight across from each other. And these two rows straight across from each other. And you can kind of, why don't you two guys compare? And then why don't you like compare with him? All right. Okay, good. I'm going to pause the video and you guys work on that. So let's see who thinks they have a right answer. And I can know if you're right or not easy by just sticking in these points. Not just one of them, but I have to put in two. Because if this point worked, it would actually also have worked if this was upside down or if it wasn't even stretched. So that point working isn't actually that big of a deal. It's if 2 points work, then you'll know you have it. All right, what do you say, sir?
So negative 2 on the outside of the value.
All right, negative because it's upside down, and a 2 because why? Why did you say 2?
Because it's a vertical stretch.
It appears to be stretching this way, I agree. And why 2?
Because it's double, it's 2 away instead of 1 away.
All right, it should be, I shouldn't have put that there, just a second. It should be a dot here, and instead of going down that far, it goes down twice that far. You are absolutely right. Okay, and now there must be something else, though.
On the inside, the absolute value is plus 2.
Plus 2, and then?
And then on the outside, it's plus 2.
All right. Now, how can we know he's right? First of all, I'm not saying he is. I haven't checked it yet, all right? I think he's right, but I'm going to check it. And honestly, I would not be done with my test question, if I were you, until I had checked. So I'm going to stick in negative 2 for x and see what I get. I put in negative 2 and I got 0, and that's 0 then. 0 plus 2 is 2, so it came out to negative 2, 2. Was that a point that was supposed to be on there? Yes, it was. And then I got to check one more. Mr. P. I use your first and last names for those situations. But anyway, what would you say would be another point I should check?
1, 0.
All right, I'm going to stick in a negative 1 because right there is negative 1, 0. Negative 1, 0. We're checking this point right now. Negative 1 goes in, and I get 1. Absolute value is 1. 1 times negative 2 is negative 2. Negative 2 plus 2 is 0. It worked. If you check 2 points and it works, you know you've got it. How many of you actually did have it right? Okay, if you didn't, can you share what mistake you made? Because it might help other people understand what mistake they made. Yes? Did you put 2 2s on the end? Oh, this 2 I bet you mean. Okay, and why does it make sense to you now that it is this way? Okay, because you thought horizontally, but this wasn't horizontal, it was vertical. Or you just forgot where horizontal and vertical are, so. All right, awesome, thank you. I bet there was other mistakes. Yes? Okay, go ahead.
So, isn't, because we were using it in the example, isn't a vertical stretch the same as a horizontal stretch?
It can be. So did you find an equation that you think works?
Not for this one, but we were doing
Okay. All right.
I saw that
The easiest way to know is, I keep telling you this, but I'm going to keep saying it until you get it. If you look at this spot over one and up one, or in this case, since we're going down, down one, if there isn't a dot there, but there is a dot here, how do these two compare to each other? Are they a vertical move away from each other? Yeah, that's why it should be a vertical change. I'll say that again. There's supposed to be a dot right here, but there isn't. Where is the dot? It's straight down from where it should be. Isn't that a vertical thing? So yeah, this one's a vertical change. I'll do another one that's actually horizontal, and maybe you'll be able to see the difference. All right, so everybody try this one now. So now we have a parabola. Now I know it might look like a V shape, but it's not. It's going to be curving. Okay, it goes through this point, and this point for sure. Those 3 points for sure work. Now this one, do you get, I'm going to go over one, up one, and say that's where the dot should be? Where is the dot actually? Vertical from there or horizontal from there? So therefore this is a horizontal change. Okay, so would you please write me an equation for that one? I'll pause for a second again while you try this one. What I will tell you on that topic is if you come up with an equation that uses a horizontal one and it works, like you can prove it works in 2 points, then there is sometimes a way to do a horizontal one that'll replace a vertical one, and they'll do the same thing, because that is true. If I take this parabola, which is, this is kind of where it should be normally, do you get I could grab it? This is like my hand, and this is like a hand. I could grab it, and I could pull it out, and that would make it go there. That's horizontal. Or, this is the weirder one. If I grabbed it here, and I grabbed it here, I could push it down, and I could make the green one turn into the red one also. So you can do them. Horizontals can be verticals and vice versa sometimes. Just doesn't always work on every function. Like what I'm telling you, this would work every time. Look and see where it should be. Look and see where it actually is. See if it's horizontally moved or vertically moved. The ones that are just a beast are the ones that have been moved horizontally and vertically, and that would be too tough to test. Like we wouldn't, that'd be like our 4-level stuff, our 3-level stuff, like what we want you to know would be to be able to handle a couple of shifts, but only one stretch on a problem like this. Okay, who thinks they have it? Raise your hand if you think you have it. All right, a few people. All right, tell me what you think.
Okay, y equals in parentheses 1/2 x times 3.
Awesome. One hint. Usually, when you put a stretch in there or a shrink in there, you should put in parentheses like that. Okay? Now, let's see. How am I going to just like look at hers and see if it looks right? Nope. I am going to test points. So here's a point that's got to be on it. 5,1. If that works in here, it's very likely you're right. 5 goes in. I get 5 minus 3 is 2. 2 times 1/2 is 1. 1 squared is 1. 5,1 works in this graph, so I bet it's right. Do you remember me saying I would test 2 points, though? Test one more point, just to be sure. How about this point? That's an easier one to test. X equals 3. 3 goes in, and I get 0, 0, 0. 3, 0, and that's on there, too. Cool, I tested 2 points. I'm confident you are right. Yes?
So when you're doing it like the opposite of 2, it would not. Why wouldn't it be like negative?
Okay, the negative would make this thing flip. Then my U shape would be like that. So I know opposite of also could involve negative. I get what you're saying, but you got to look at the picture. And if the picture is upside down, then it's got a negative. All right. Let's do one more since I'm still not sensing a whole lot of confidence. Remember, we're testing on one of the hardest ones. There's a lot of easy ones too. Okay. All right, let's try this one. here is one of these square root shapes. Just to clarify, this is what the normal one would look like, but that'd be too easy. I'm going to give you one like it. Maybe it would actually help you to find the equation of the black one first. And then I'm going to ask you to find the equation of this blue one. Try an equation for both. Black one, that's like the easy level. Blue one, that's like R3 level. I'm going to pause for a second while you find a couple equations. Okay, the easy one. It's a square root function. It's been moved 3 to the left. It's been moved up 2. Notice that's on the outside. And it hasn't been stretched or flipped, so that's pretty much it. Raise your hand if you had that one right. Okay, that's easy level. X plus 3, and then outside plus 2. Hard level. Well, it's actually pretty much the same as that. X plus 3 plus 2. But this one's got a what? A 2, a what? What's it called? A vertical stretch. Factor of 2. And if I needed to make sure this was right, I would grab a point. Like, let's say this one, which is 1 comma 6. If I put in a 1, it better give me 6. And I get the square root of 4, which is 2. 2 times 2 is 4. Plus 2 is 6. It worked. 1 comma 6 worked. And I'll check one more point. How about that one? Negative 3 comma 2. When I put in a negative 3, that all cancels out, and the answer is 2. Cool. It works. Okay, that's all the time we can afford to spend on that. If you wanted to, you could stay after school for a little bit today with me. There is no morning help time on Fridays. So Mondays, Wednesdays, and Thursdays, you get morning help, but not Fridays. So then, if you really want help for the test tomorrow, your only hope would be to stay after school today. There is, of course, a review key and a review worksheet. So, like with, you got all the answers and all the problems. So, believe me, it's a lot harder to study for the pre-calc test next year because we don't give you a practice test. Here, you get a practice test with all the answers. That ought to help a lot. You can use that tonight. I'm not cutting any problems out of it because it's the review for the test, so it's really important. If you've been kind of slacking till now, you could make up for a lot of it by just a really strong performance on tonight's homework and then doing well tomorrow. Okay, so let's go over a lot of little topics. Here is a square root, and it's also been stretched, but I don't even care exactly where because all I need is that to get the domain and range. See if you remember how that works. Domain's this way, and the range is an up and down thing. What's the domain and the range of this red function that starts right here? Pausing for a second. Okay, one thing that sometimes kids do that I think works pretty well is like domain is this way and it goes forever that way and it stops right there. Why did I do that on the x-axis? Because that's what the domain's about. Okay, so it goes from here to here. So how would I say that? From 1 to infinity, and it touches 1. Raise your hand if you had that one right. Okay, then the range. You could do that on the y-axis. It goes from how low does it go? 0 to how high does it go? 0 to infinity. And it touches 0, so bracket. Okay, how many of you had that one right? Okay, good. Next little topic. If this is f of x, it's got like 3 parts to it. Straight part that's like a ramp going up, a flat part, and then a curve at the end. If that is regular f of x, would you please draw for me what 2f of x would be? I'd do it on graph paper if I were you. Like import a little piece of graph paper. A lot easier if you have a graph paper. So this tests if you know that the stuff on the outside is vertical. So are you doing a vertical stretch to it? Good, that's what you should be doing. If I were you, I'd start by graphing the original one, the parent one, and then I'd take each point and stretch it vertically twice. 0, 0 when it gets stretched, doesn't stretch at all. 2, 2 when it gets stretched, vertically goes up to 4. 5, 2 goes up twice as high, and then 7, 4 goes to 7, 8, and here's my new graph. Just to clarify, is it any wider than the original one was? No, it's just vertically twice as tall. The green one's twice as tall as the blue one was. Do you want another one like that or not? I want you to either go, nope, I don't want another one like that, or yes, I want another one like that. All right, I got several yeses, so I'm going to try one more like that. It won't be the exact same. Question? Okay. Let's take this same original then, and let's try this with it. Negative f of x on the outside. If moving the whole shape isn't working for you, try just taking the 4 key points that are on it and reflecting those dots. Then you can connect the dots at the end. Okay. Now let's do this with red dots. Where does that one go? Stays. Doesn't go anywhere. That one goes down here because I did a vertical reflect. That means, is it any wider? No. Only thing that was changed is the vertical, and it's not even taller. It's just flipped vertically. And then this one, which was 7, 4, is still over 7, but this time it's down 4. 1, 2, 3, 4. I was going too low there. And then it's a straight line, and this part's supposed to be curved. Here we go. Yeah, spaceship. Who had that one right? Okay, good. Let's move on. Different type. The most missed question on the last PSAT test. I want to remind you what circles look like. I'll do this one, you do the next one, so pay attention. First of all, a normal circle, like the classic circle, is just a little circle with a radius of 1, and it starts at 0, 0. So this one has been moved to a different spot. It moved to the right 3. Does that look like right 3 to you? You getting used to that by now? Okay, that's right 3. And then this, I better put a Y in there. My bad. I do that every now and then. Okay. This has been moved in the Y direction, which is up, down. But is it up or is it down? And how can you tell? Seems like it's up to. Why is it actually down to? It's on the inside. Okay. So this means right 3. This means down 2. And this means it has a radius. Please don't say 16. False. 4. Because 4 squared is 16, right? So I can replace the 16 with 4 squared, and then it repeats the pattern. Squared, squared, squared. See? So the radius is 4. Now I'm going to make myself a circle that has a center at, well, to the right 3, doot, 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 and then down 2, doot, doot, and there's the center. And then it has to have a radius of 4. 1, 2, 3, 4. 1, 2, 3, 4. I'm just going to go 4 in every direction. And then I'll try to connect those dots. There's my circle. Did that make sense to you? Let's see if you can do one then. Again, don't underestimate these because most missed test on the most missed question on the PSAT. There's a lot of kids that take that. All right. So here's x plus 1 squared plus y minus 7 squared equals 4. Pause for a second while you give that one a try. Okay. If you haven't got it by now, you're probably missing something important. So, right 1. Oh, no. Left 1. Down 7 or up 7? Seems like down 7. But you don't trust it because it's on the inside. So you go up 7. So, I'm going to go 1 to the left, up 7. There's a dot. And I'm kind of in the way of it. So, I'm going to move this stuff down. 1 to the left, up 7. There's a dot right there. Awesome. And then the radius of 4, right? No, I'm a mistake. I'm going to mark wrong a lot. What is the radius? 4? What is it? 2. Because this is really 2 squared makes 4, right? So it's 2 for a radius. So hopefully you didn't get fooled by that. There we go. Any more questions on circles? All right. Toughest function is not a circle, though, in my opinion. It's this guy. Everybody graph just the parent one that looks like that. And if you get stuck, remember the XY chart is your best friend in graphing. You can find any graph with the little XY chart. Do you remember that this is the only one where I'll let you graph it with only 2 dots? All the other ones you need 5 dots, unless they don't fit on the page. But most times it will. This one, 2 dots. That's it. 1, 1, and -1, -1. If I didn't know what the dots were, I would just try stuff. Put in 0, and I'm like, wait a minute, 1 over 0, that's not good. Not going to try 0. Or I'm going to be really smart and go, that's the asymptote. I'm going to put in 1, and then I get, when I put in a 1, I get 1 over 1, which is 1. 1, 1. That's this dot right here. Okay, then, how many of you knew there were, I'm going to make them bright pink here, asymptotes here and here? Raise your hand if you put them in on your graph. Because if you didn't, you would not get full credit on the test. Okay, it'll say in the directions, don't forget the asymptotes, but it'll say that on every problem. But this is the only one that has asymptotes. Okay, so don't forget that part. All right, so then these lines just get closer and closer to the asymptotes. There we go. I've graphed 1 over x. But this is an honors class, so you probably would have to be able to handle it if I said 1 over x plus 1. Now, is that on the inside or is that on the outside? On the outside. I had kids say, look, Mr. Server, I put it on the inside. Nope. Because if I take those parentheses off, it's still on the outside. How could you put it on the inside if you wanted to? That plus 1. How could it get inside? Put it down by the x. That's what would move it left 1. It has to go down inside, and so I started, once you get like into the more advanced, I usually say inside by the x, because that works on all of the functions too. If you're having a hard time telling where exactly is inside, it's inside is right by the x, right in there. That would move left 1. This would move it up 8. So that's left 1 and up 8. And the easiest thing to do is actually to move the asymptotes. The asymptotes go left 1, that doesn't really do much. But that one moving does do something. There we go. I just moved everything left 1. Oh. There. 12-minute warning. And then I have to move everything up 8. It's a little bit of a pain. Okay. So that's one of the hardest functions. Then I'm going to stick with just moving it left 1. I'm not going to try to move it up 8 because it takes too long. Now that I got it moved left 1, I should probably get this out of here. Get that little green one out of there. Now here's one of the tougher questions too. What's the domain and range of that picture? Hint, it's got 2 parts to the domain because as you go from left to right, there's 2 zones where it works, and there's one number that doesn't work. So as I do domain, I think to myself, how far does it go way to the left? How far is this function right here going to go as far as way to the left? Negative infinity, so that's a good start. And you can't ever touch infinity, so I put a parenthesis, and then I say comma. And then I got to ask myself, when does this stop working? As I'm going from left to right, what's the moment when this should stop? It's like it starts here, and when should it stop working? At 0. But wait, this one's been moved. So this one isn't 0. When does this one, with the little pink asymptotes, when does that one stop working? Not 0. -1. Get why it's -1 this time? Because I moved it over a notch. This is not the normal 1 over x function. This one's been moved over. The pink asymptotes, they've been moved to the left 1. Then I say union with another little group of things that work. And that is, whatever number this was, it's the same number again. -1 to, and it keeps working forever, which is also known as infinity. Yes.
How is that -1?
Okay. See this dotted line right here? That dotted line isn't on the axis. You get the axis is right there. It's one spot over. That's the number it can't be. Okay, this is not a normal. If it was a normal one, if it was a normal 1 over x graph, it would have been 0. But this is an 1 over x that's been moved over 1. Another way to think of it is this. If I put in -1, see how it crashes my function? That means that's the asymptote, is -1. Okay, now how about the range? Did I ever move this function up? No, so its asymptote's in the same spot as it was before. In the up-down direction, what's the one thing you can't be on this? When it goes from up to down, what's the one thing you would be stopped by? The electric fence. Right there. 0. Okay, so it goes from -infinity to 0, union with 0 to infinity. Why 0 again? Because as I'm going up, down, that's what range is. It goes forever down. It just stops working when I hit 0. Then it starts working again right after 0 and goes forever. All right. Yes? It does matter what order you put it in. The smallest numbers have to always be on the left. And since -infinity is the smallest of all numbers, it'll always be on the left. Do you want another practice one like that? Yes or no? Nod your head or shake your head. Quite a few nodding heads. Not everybody, but I'm going to do a quick one. I'm going to move these asymptotes over. I'm going to go to like 2 with that one and 4 with that one. We won't stretch these. It just gets too complicated. So it's just moved. So here's the question. What's the equation for it? And what's its domain and range? This one's been moved 4 to the right and up 2. Really stay focused with me here. If you can finish the hour strong here. You have plenty of problems to go home and practice. If you know you need one-on-one help, stay after school. I'm going to say something that's true, and it might be, I don't know, scary for some of you, but conferences are next week. So I'm going to see a lot of your parents. I typically see about half of your parents. So half of you, I'm going to see your parents. It'd be a great test to have done well on, because it's a hard, not super hard, but it's, it's not an easy test anymore. The first couple ones were pretty easy. This is a harder test, and if we can say, hey, your kid just got a straight A on the hard test, well, basically conference is over. Nice job. Way to go. Okay. If you struggle, we'll have to be talking about, there is a retake. And the retake is next week. It's on a cumulative test. How many of you have had cumulatives before? That's only a few of you, so let me explain what it is. That's a test next week that includes the same stuff. It's like a second chance at it. But it also includes Chapter 1 and Chapter 2. Now, you actually have been using those things so often that it's not like you've forgotten Chapter 1 and 2. They were actually super easy. When you look back down them now, you'd be like, oh, that was back when life was easy. All right? So that part, you'll do fine on. This new chapter is the one that actually will be tough again. But study hard for it tonight, and then you get to have an easy test next week, because you already got this stuff. If you get it down tonight. All right. Did you have 1 over x as kind of the base function here? Good. Then, did you get it moved right 4 by doing a minus 4 on the inside by the x? Okay. And then last, did you get that it moved up 2? So I'm going to do a plus 2 on the outside. Make sense to you? Okay. Then, domain and range. How far does it go this way? Negative infinity. And then if I go back this way, when does it stop working? Right there, at 4. So negative infinity till 4. And then, when does it start working again? Right after 4, and it keeps going until infinity. Raise your hand if you had that one right. I'm glad we did it, because there's still a few people getting it wrong. Okay, the range. How low does it go? Looking at this red thing here, do you get it's headed downwards? It's going to go to negative infinity. Then, as you're going in the y direction, you were down here, I think it's going to stop working right there at 2. Union with, starts working again right after 2, goes to infinity. Okay. Now, I've gone through a lot of important, tougher things. Does anybody want to ask any questions? Like, when on the homework I had trouble with this. The only thing I don't want to do is ones where they did a double. They made it go horizontally stretched and vertically stretched, because that's too much. It's good for a challenge, but we wouldn't ask anything to graph anything that hard. Not seeing any questions, so I'm going to give you one more that I feel like is representative of this test, because there's a lot of graphing. Okay, so let's just see if you can simply graph this. And I hope you lean on your XY chart a lot. That is as tough as it would ever get. It's got absolute value bars, so hopefully you're like, oh, so it's a U shape. No, it's not. Hopefully you know what shape it is. And then, if I were you, I'd be like, oh, I think it's going to be stretched and flipped, and I think it's like generally over here. You know, kind of just generally put an idea of where it is. That's not saying that's right. It's not. Figure out generally where you think it is. Then go for the XY chart to find out exactly where it is. All right, I'm going to pause while you try that one. Okay, so I had a few kids who wanted to see the answer to this one, and we finished it as the bell rang, so I'm going to record this ending here. So if I was going to graph this, first of all, my gut says it's a V shape that has been flipped over, which makes it like this. And then it's also been stretched and moved to the right. So here's my moving it to the right, and then my stretching it would mean it's like a little more pointy like this. And then it's also moved up one. Okay, so the idea is it's moved up, it's in that neighborhood. Now how do I get the final answer? XY chart. On my XY chart, I'm going to find things like 3, 4, and 5 and stick them in. If I stick in 3, I get 3 minus 4 is negative 1. Absolute value is 1. 1 times negative 2 is negative 2. Plus 1 is negative 1. And did I have 3 comma negative 1? I did. Look at that. I did it right. Now I'm going to try another one. Let's put in 4. If I put in 4, I get 0 here, which means all of that's 0. Plus 1 makes 1. 4 comma 1. Look at that. I did that right too. I can tell I was on the right track. I'm going to try one more point. I'm going to put in 5. If I put in a 5 here, I have 5 minus 4 is 1. 1 times negative 2 is negative 2. Negative 2 plus 1 makes negative 1. 5 negative 1. Look at that. My graph is working. You need 5 points. I've only done 3, but class is already over, so I'm going to stop this one. Hope that you're ready for test tomorrow. Do the whole review worksheet and check it with a key.